Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is count the number of consistent strings. So let's go to LeetCode. Alright, you are given a string called allowed consisting of distinct characters and an array of strings called words. A string is consistent if all the characters in the string appear in the string allowed. So return the number of consistent strings in the array words. Well, really simple, right? We have just done a problem, find words that can be formed by the characters, right? This is exact same problem, just the wording is a little different. Now we are checking if any of these words only consist of the characters that are given in the allowed characters. So really simple. So now we are checking if all the characters in each word, they only contain the allowed characters. So whatever is the number of words that contain only allowed characters, we will return that number. So taking the first example, we are given allowed string, then we are given words. We need, our result has to be the number of words that only contain the allowed characters. So what are the allowed characters? A and B. So what are the words inside our words array that only consist of A and B? So let's check. So the brute force way of solving this problem would be, for each word, what I would do is I will check each and every character of this if that character is present in my allowed. All right, so here what I'll do is I will go through all my words and then check if A is present in allowed. Yes, it is. Is D present in my allowed? Well, no. So that's why this is not the word that I'm looking for. My result is still 0. Then I can just say it's 0 right now. Then is B present in my allowed? Yes, it is. Is D present? Well, again, it's not present, so that is why this will not be the character that I'm looking for. How about B? Well, all A's are present. B is present, so that is why yes. How about BAA? Yes, you can say the B and A both are present in your allowed. How about this one? So now my result is actually 2 because I found 2 words that have the characters, all of their characters that appear in the allowed characters. Now here B is present, A is present, but D is not present, that is why no. So the brute force solution for this, checking it this way, would be we will actually visit all the words. So let's say so I'm writing the brute force right now, brute force solution. That would be for each word in my words, I am basically for that word. So for the CH in word, I want to check if all the characters in word, the CH character, if CH in allowed. So if you are doing this approach, now here, if let's say the length of allowed is let's say A, length of word is longest word's length is L, and then all the words length is W. In that case, the time complexity for our solution would be, it will be basically for each word you are visiting, basically you are checking for the length of each word, so W into L into A. Okay, so this is the time complexity, and for space complexity we have constant space complexity. So this is the brute force approach. Here you can already see that this is not optimal, right? We can definitely bring it down, and we will bring it down. So how we can bring our time complexity down? So if you see, what's the repeated work? This is the repeated work. Here I am visiting my allowed string again and again for each character. Can I reduce that? Can I bring that to big of W into L? Yes, I can. How will I do it? Rather than iterating again and again on the allowed string, I can just put all the characters into a set. That will give me constant time complexity to check if some character is present in my that set. So instead of this right here, what we can do is we can make our solution more optimal. Here for CH in word, if this CH not in, I'm gonna turn it into allowed set, that will be basically a b in this case. So if this is not in allowed set, then you basically break from here. Okay, so this word is not consistent. Okay, so you break from here. Otherwise you basically come, you can have I would rather have like a maybe a flag here. So flag initially will be true, and here if when I'm breaking, before that I will mark the flag false, just like how we have done in the characters, words that can be formed using those characters. So chars problem, that's the problem that we have done in the series earlier. And then if that flag is still true, then you can increment your result by 1. Okay, and then you return your result. These are simple problem, really easy problem, and you shouldn't be on this video right now. You should be just like writing your solution, multiple solutions, like just modify these, like, and see what gives you a better time complexity, if they do. Although like there won't be much changing here. Okay, so let's code up our solution. Alright, so I'll have my result initially 0. Then what I want to do is for word in words, and for this word, before I move forward, I will create allowed set, and that will be the set of all the characters in allowed. Alright, so that's how you can create it. I think that's how you can create it. Now let's go over all the characters. So for ch in word, if ch, before I do that, I will have is consistent true. This is consistent true, that word. And if ch not in my allowed set, then I will mark this is consistent equals to false. If is consistent is still true, but I will break it from here. But here, if this is still true, it will come to this consistent, then I can just increment my result by 1. Alright, finally I can just return the result, easy peasy. These are like, you write these solutions like in 1 minute, try to write them under 2 minutes, 1 minute. You don't have to though, like I'm just bragging. So okay, so let's test it on the example cases, and yes, let's submit it. So time complexity, yeah, that's pretty good, right? 95%. Big of n, I would say w, that's the length of the words array. W into the length of the longest word, because you are visiting these for each word. But to simplify, we can just say the longest word in our words was like, let's say L. That will give us the worst time complexity, because for each word the length is L and we have to visit all the words. So L into the length of all the words. So W is the length of all the words array. For space, well, we did introduce some space from the brute force solution, optimizing the brute force solution. So that was big of allowed set. So we named it A. All right. So A, the A is the distinct character. So that's pretty good. So now it's all done. That's the entire solution. Let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.